Bismillahirrahmanirrahim. Assalamu alaikum to all my viewers and students. Welcome to my channel, and please subscribe my channel for further videos related to the SmartPLS version 4. And if you have issues in regarding in your data analysis part, you may contact me on my given contact information. Here today I am going to show you that how we can work with the higher order construct, and this would be the first part of the higher order construct analysis. I can show you here that this is a base model that is taken to analyze the higher order construct analysis in SmartPLS version 4. You can see here that this is my independent variable, and it comes with the 5 dimensions listed here. Similarly, the dependent variable is the project success, and it also has a 5 dimension, and each dimension is measured with the number of items. A strategic renewal is my mediator, and it is a first order construct, mean it has no dimensions, and similarly this is the my moderator, project manager competencies, and for project manager competency further it has a 4 dimensions. And it is very interesting, this model, that it comes with a moderator, and moderator also has a higher dimension. In most of study you have, if you watch the videos in your YouTube, uh, most of the study use simple dimension with the your independent variable or dependent variable, and very less videos have shown that the a moderator with a high dimension, and how it if analysis performed with the second order construct or moderator. So I will show you in my video today. Let's move towards SmartPLS version 4, and to save my time, I first made the base model that I have shown you in my slide in SmartPLS version, and you can see it here. This is my base model, and here is my independent variable with the 5 dimension, dependent variable with the 5 dimension, and each dimension has its own measurement or the items. Similarly, the moderator comes with the 4 dimensions, and the mediator is the first order construct, and it has no higher order dimensions. And this model is drawn for higher order construct analysis, but to show in a simple way, this will become more complex if I go to analyze this model at this stage, and the student will not be able to understand clearly. So I start it with a simple way, or by taking a simple 2 dimensions of each variable that can easily be interpreted. And after that, once your understanding is done with this model, we can then run simply this model and analyze the effects of this model in SmartPLS 4. So I am moving back to the main window, and here I am going to create a new PLS SEM model. Definitely there are 3 options: PLS, SEM, regression, and process, but we are working with the latent variables, mean items of questionnaire. So we will choose new PLS SEM model, and we let me name it as a simple HOC, higher order construct model, part 1, and this is my part 1 of this video, and the complex model will discuss in the next model. I have basically 5 dimensions of the independent variable, that was entrepreneurial orientation. I'm just taking 2 dimensions of it. For example, the first is the innovativeness, and just select the number of items and drag here and enter. it will automatically create the latent variables, and most of the students are now familiar is with the working with the SmartPLS software. These two dimensions for the independent variables, and here these let me off this variable measurement. Further, this is my mediator. Let's take the mediator here, and it has three items, and let adjust its item above. So next is the moderator. Let's take the moderators two dimensions also, enter, and we should take dimensions which have a less number of items. Then we move towards dependent variable, take the first dimension of it, efficiency. Then we take the let's suppose let's take the impact on customers, and I have taken these dimensions of each construct, so can easily be understood that how basically it works with the sorry how can easily be we work with these dimensions. Let's move this here. uh, I am building this model here that we can easily work with it. Okay, now the first stage says in most of author says that first you need to validate your model or perform its confirmatory factor analysis on its first stage. The author says that if you are working with this type of model, you have to analyze the model fitness at the first stage, and that is called first stage by taking how you need to draw the first stage variable or first order constructs. And I am not here taking the second order construct, but like I show you my earlier model with the complex model, and drawing this model at first level becomes very complex. But for the sake of simplicity to understand the concept that how actually it works, I just show you that how can we work for higher order construct in a simple way. The author says that at first of all you have to draw the first order construct and connect each variable with the respective variable. For example, iv to be connected with the dependent variable, and both IVs are connected with the dependent variable. Similarly, for second independent variable, you have to connect it with the independent dependent variables, and then you have to also include the mediator, and with the mediator relationship, simply mediator with a dependent variable. Now if you see here that I have drawn the two IVs effect on two DVs, although these are the dimension of the dependent variables, and similarly this is mediator, but it becomes a little bit complex. Now when I draw a model for moderation, then how I will draw this moderation effect here. So at first stage, when we want to validate the model, and now the you can see you can say that the issue becomes when you apply the moderator effect. But basically we here exactly want the test the confirmatory factor analysis of these model, you can connect these moderator with any of the variable, and it will automatically will be considered as a working for the confirmatory factor analysis. I can show you that you can connect the like this moderator attentiveness with the this independent variable, and this communication could be connected with the efficiency, or it could be also connected to this variable or any of these variable. So in this case you can see that we have just connected the lower factor or first order construct with the each other, and just here we are going to analyze the confirmatory factor analysis of all these constructs. In the second part of this video I will show you that how we will do the same thing with using converting it into a higher order construct. But at this stage let's go to the calculate option, and as my all variables are the reflective measures, so we here used a consistent PLS SEM algorithm option, and just we click on the PLS SEM algorithm, not with the bootstrapping, because at this stage we are not actually measuring the path analysis, we are just doing a factor analysis. So in PLS setup click on the factor analysis, and data will remain the same, and setting types of results definitely on, it is preferred that it should be on standardized, and other things remain the same. Just click on the open report option and start calculation. Now the analysis has been executed and the definitely results are generated, but here in this level we are concerned about the factor analysis, and we have to check its conversion validity and its discriminant validity at this level for these constructs. Then we will move towards the other analysis like structural equation modeling and etc. So here you can see the R square values are given in within the blue icons, and these are the R square values of the each model, and definitely the inner model shows the path coefficient, and for outer models there is a outer weights are outer loadings, and for reflective model it is preferably use outer loadings. You can just view here that which items has a loading greater than or less than for a certain variables. If the loadings are less than 0.70, then that may create an issue in your data analysis part, but you can is further test it from on the result report. Let's go towards the result report. The first option is here is the path coefficient, and again I have told you that we are not interested with the path coefficient analysis at this stage, because we are just validating the model, and for validating the model you can directly go to the quality criteria option, and there you can check R square. R square is not required, F square is still not required here. We need to check here the construct reliability and validity, and construct reliability and validity, here the construct reliability and validity shows that there is a no issue of convergent validity in our model, because all the items or the first order variables have the Cronbach alpha higher than 0.70, rho is also greater than 0.70, composite reliability is also higher than 0.70, and average variance extracted is also higher than the 0.50. So there is no issue in our convergent validity, and the construct reliability is okay, that we can move with this model. Further, for discriminant validity, you can have two options here. The first is heterotrait monotrait option. Heterotrait monotrait options is in my previous videos for the uh, mm, analysis. I have mentioned that it should be for heterotrait monotrait the value should be less than 0.80, and if the values are less than 0.08 0.80, then there is a no issue of the construct discriminant validity. So if the all values are less than 0.80, then there is a no issue of the construct discriminant validity. Then you can say all the values are green. If they are marked as green, that it shows that there is no issue in our data regarding discriminant validity. If the value becomes greater than 0.80, then the value becomes red in this table. So here is no issue of the construct discriminant validity. Further, the discriminant validity can also be checked through the Forner-Larker criteria, and the Forner-Larker criteria is basically the items correlation. It is a correlation table between the variables and on the diagonal it is the square root of the average variance extracted values, and the criteria says that if the diagonal values are higher than the lower values, then there is a no issue of discriminant validity. And if any of the value below this becomes higher than the diagonal value, then there is an issue of the discriminant validity, and that could also create a issue for the multicollinearity, because sometimes two or more than two variables become collinear, and therefore their correlation becomes higher than the square root of the average variance extracted. But in this case here all the values are less than their diagonal values, so there is also no issue of the multicollinearity as well as discriminant validity. You can further check here also that the any IF item has higher than the 0.70 correlation, but all the items has the very low correlations. It can be further analyzed through the collinearity statistic, that is a VIF, and for VIF threshold criteria is that its value should be less than 3.30. so this confirms that the its value of each item or item correlation for outer model mean it measure the VIF for the items, and each item has less than 3.3 VIF, so there is no issue in the collinearity statistics also. For inner model it should also be less than 3.30, and the green table shows that there is no issue regarding this at this stage also. So here we have no issue of model fitness, and further you can also check the model fit measures for saturated model, and saturated model says that the SRMR is less than 0.08 and it is 0.046, and upper limits and lower limits are within the range, and simply chi-square value NFI must be near to 0.90, preferably its value should be near to the 0.90, and it is showing 0.6 to 1. There should be a certain issue with the NFI for measuring, and here are the Bayesian information criteria. You can also code this one there. You can check here the outer loadings for creating issue if they have. Definitely it creates a table here, and you can see that the attentiveness has 5 items, and each item has loading greater than 0.70 communication. You can see here that the communication for communication, the one of the value is giving a high score of 1.167 and the other is a 0.470. So this could be a little bit alarming, but it has no due to, I think, communication higher value, the other values are be ignored, and the in our construct reliability the communication was also has the 0.850 and higher value of average variance extracted, so there was no issue of construct reliability here. But it can be looked there also that it it's one of the factor has high loading and one of the factor is very low loading. Secondly, you can check out the efficiency. Similarly, efficiency as 0.870 high value and 0.739 for the fourth one, and the two others are a 0.681 and 629. You can say here that these two values are less than 0.70, but overall if there is a no issue in average variance extracted and Cronbach alpha and composite reliability, then you can go with these items and perform the analysis. If the issue remains with the average variance extracted and composite reliability, then you have to remove one of the item with the lower wedding to loadings to improve the model fit measures. Similarly, you can check other variables also and analyze the effect. Definitely when you are writing your results, you have to copy this table and your Word file are in Excel, and after certain formatting you can copy all the desired results, like for example while you write up confirmatory factor analysis, you need to build a table of the auto loadings with the value of the construct reliability and validity, and after that you have to show the heterotrade ponotrade for discriminant validity. This table and for Farner-Larker criteria is also used for discriminant validity, but it is also used for the to analyze the correlation between the variables. So this was about the uh, first order construct here, and I show you that if it becomes complex when we deal with this type of model, and we directly want to analyze their effect in a with the second order dimensions instead of drawing this type of complex model. And I think I have to make another video, or I will show you in next video that how we will deal with this type of model and use the first order or more perform confirmatory factor analysis direct drawing the second order construct, and in this way that will be, I think, easy to analyze these relationship. And then I will also show you that how basically we will get the confirmatory factor analysis tables, and results will be drawn to interpret in your manuscript. Thank you very much. It's enough for today.